Hi, my name is Jose Sanchez, and this is my final project for CS122A for fall 2018. This is the in-depth portion of the video analysis. Now, to start off, we'll quickly demo what's going on with the tank itself. The tank, go over the features. It features 2 motion sensors on the left and the right-hand side, 4 DC motors, electric DC motors, and a servo motor mounted on top to act as a tank barrel. So quickly demo the tank barrel. If we hold left on this button, or if we hold this button, it will rotate to the left. If we hold this button to the right, it'll of course rotate to the right, and it can rotate back in the center. Now we'll look at the joystick itself. The joystick controls the directional input, so it can move forward, backwards, it can move to the left, and it can rotate to the right. Of course, it's struggling a little bit to rotate, just because some of these tires get a little more grip than the others. Also, the surface is a little grippier. It works best on a classroom surface where the tile's a lot slicker, such as in lab. But that's a quick demo as to how it goes about it. Additionally, looking at the tank portion real quick, the tank itself takes input from this Bluetooth module using UCR, and that Bluetooth module gets its information from its other Bluetooth module here. Of course, the joystick gets a signal. I'm trying to find the light. The joystick information, or the atmega, gets a signal from the joystick information, and that joystick information is then converted into a 4-bit number that can then be sent over UCR, so this atmega can process everything. In addition, these 2 buttons use the same UCR portions, but instead send either 0x00 or 0x01 or a 0x02 to determine the direction that this tank nozzle will turn in. So as mentioned previously, the joystick sends a 4-bit binary number, and this binary number is used to process the information on the driver motor mounted on the very bottom here. So as you can see here, the HC05 Bluetooth is connected to the 2 portions of the RX and TX, and then that information is then processed, the 4-bit number is then processed and sent into port B, which is then sent directly into this driver motor, which determines the direction in which the power will flow for these 4 electric DC motors, which gives us the ability to both turn left, right, forward, and back. In addition, the servo motor is simple. It's connected to D5, and all the information is within the code. All it does is determine the ORC1A, the values for ORC1A. If it's high and we can still rotate to the right, we continue to rotate to the right. If it's low and we can rotate to the left, we continue to rotate to the left until it meets the value that's too low. Once the value is too low, it will stop. In addition, if it rotates to the right and the value is too high and we want to rotate to the right, it will stop rotating to the right. Additionally, we have 2 motion sensors on the left and the right hand side. So if anybody tries to sneak up on you, tries to come up, this light will flash rapidly, as you can see here. Try to get to focus. So you get too close and the light will flash rapidly. And that's to let you know that someone has come up on your left-hand side. So if this were a real-size tank, you're mounted inside, you really can't see on your left and your right. But it'd be good to know what's in your proximity to see who's trying to mess with your tank. Left, right, and it also works if you have 2 people coming up on both sides. Works just fine. And that is all done through code on the atmega. Thank you. This has been my final project for CS122A, and I hope you enjoyed.